Determine the angle theta for connecting member A to the plate so that the resultant force of FA and FB is directed horizontally to the right. Also, what is the magnitude of the resultant force? Okay, so they're saying that we're summing FA and FB and getting a resultant force that's ends up being directed horizontally to the right. So this is FR. They want to know the magnitude of FR as well as what theta needs to be to make this happen, if these are the magnitudes of FA and FB. All right, so we're going to do this graphically. It would be much easier to do this with the XY coordinate system and I hat and J hat, but we're going to do this graphically for practice. So it's really helpful to draw as much to scale as you can when you're doing a problem like this graphically. So let's draw FA and FB to where their differences in length are to scale. Okay, so this is FA and .33, so FB is 1.33 times as long as FA, or FA is 1.333 times as long as FB. So about a third of the length of this vector. So this is half of the length. Let's break it up into thirds. So about right there. Okay. All right. Let's draw this coordinate system or the coordinate axes here. So okay. So FB, let's put this at 40 degrees. Okay. There's FB. And then FA is like that. There's FA. Okay. Now, well, let's first put them head to tail. Then we could see that's going to be the resultant along the horizontal axis. Okay, so we can now draw the resultant. You see, because this is FA, FB. This is the triangle method for summing vectors. So this is the resultant of FA and FB. But now let's take FB and bring it back here because we want to, it'll be easier to solve for this angle. Well, we don't have to do that. Let's leave it like this because this is the angle. We're just solving for this angle here. So let's change it up. Well, what we want to do though is we don't want to lose this angle here. So let's draw a horizontal and vertical axis here. And this means that this is 40 degrees. You see? And that means this is 40 degrees. And this is theta. Okay? This is 8. This is 6. And this is FR. Okay, so we still need another angle or some other piece of information. So let's take a look at the geometry here. Well, we can see that, so these two lines are parallel. There's a transversal, so this is theta. And we know that this is 90 minus theta. So does that give us, if we say 180, if this is alpha, and we add all of this up, does that end up giving us some information? So this plus this plus this is 180, right? So 90 minus theta plus theta plus 40 plus alpha is equal to 180. So these go away. 90 plus 40 is 130. Okay. Alpha is equal to 50 degrees. Okay, so now, but we still can't find theta, so let's keep looking at these angles here. If we extend this, okay, what do we have? We should be able to match up this 40 somewhere over here. Well, I'm not sure what I put. It's more of like this is 40. Yeah, I don't know what I had put before. This is theta. Okay, what do we have? Okay, these two lines are parallel. Here's a transversal, so this is 40. This is 40. Now this is 50, right? That's alpha. This is 50. What is this? Okay, so I can't find any angles. What else can we do? Well, okay, yeah, we could try the law of sines because, yeah, we could do this. So sine of alpha, sine of 50 over 8 is equal to sine of 90 minus theta. Yeah, that's it. Okay, sine of 90 minus theta over 6. Yeah, that's okay. There we go. Okay, so sine of 90 minus theta is equal to sine of 50 times 6 divided by 8.574533. So 90 minus theta is 35.1. Okay, so theta is equal to, it's going to be 90 minus 35.1, 54.9. Okay, so now that we have that, we can just use the law of sines or the law of cosines to get FR. So FR is the law of cosines. Will say that the square root of 8 squared plus 6 squared, so 64 plus 36 minus 2 times 8 times 6, so 2 times 48 times cosine of 54.9 plus 40. That's 94.9. Okay. All right, now 10.4. And that is kilonewtons.